Hi everyone. Okay, so now we're going through the problem about the centers of a triangle. Precisely, this problem is about the center, the circumcenter, and the orthocenter of a triangle. So we try to look at the relationships between those two centers. So in this problem, we are going to consider a triangle ABC with orthocenter H and circumcenter O, and let M be the midpoint of segment BC. Suppose that line AH intersects segment BC and the circumcycle of triangle ABC at the points D and X. So we have a triangle ABC. Here is our circumcenter and here is our orthocenter. Of course, orthocenter is the intersection of the altitudes, and M is denoted as the midpoint of BC. So we have M here as the midpoint of the segment BC, and the line AH intersects segment BC. So line AH, the altitude, intersects segment BC and the circumcycle of the triangle ABC at the points D and X respectively. So D is the intersection of this line and this segment, and X is the intersection of the same line and the circumcycle. So we have our point D here and our point X. And then finally, let line AO meet cycle ABC at the point Y. So line AO, we join the vertex A and the line through the circumcenter, and the intersection here will be denoted by the point Y. And we are required to show that D is the midpoint of segment HX. We are required to show that this point here is the midpoint of this segment from H to X. And we're also required to show that M is the midpoint of segment YH. So M is also the midpoint of the segment through Y and H. And then finally, we're supposed to show that this angle BAH is the same as angle CAO. So to deal with Roman 1, so for the first part, we want to show that D is the midpoint of the segment HX. And so what I will do, I will actually prove that these triangles here, triangle BHD and the triangle BXD, they're actually congruent to each other. So I will join the segment from the point B to the point X. So now we have this segment here. And what I want to do is to show that this triangle here, these two right triangles, are actually congruent to each other. And to do that, I will do a little bit of angle chasing. So because this point lies on the circumcycle of the triangle ABC, then it's not hard to see that this angle here, subtended by this arc CX, will also be the same as the angle at the point A, subtended by the same arc CX. So that angle will be the same as that angle over there, right? So this angle is the same as this angle. Also, because we know that we have a right angle over there and also a right angle over there, because this is the orthocenter, then by the properties of cyclic quadrilateral, we know that the quadrilateral AB, if this point is point E, then ABDE is cyclic. That means these points, the 4 points A, B, D, and E, will lie on the same cycle, because this angle subtended by this segment AB is 90 degrees at both points D and E. So this quadrilateral is cyclic. And for that reason, we necessarily have this angle, the angle subtended by segment DE, will also be the same as this angle right there, subtended by the same arc. So this angle here that we have drawn will also be the same as the angle right here, angle HBD. And so now what we see is that this angle is the same as this angle here. Here we have a common right angle. They are both right angles. And so finally, this angle will necessarily be the same as this angle here, right? Because the total sum of angles in a triangle, they will add up to 180 degrees. So these triangles are similar, but we see that they share a common side, right? They share a common side, which is BD. So I have shown that triangle BHD is similar to triangle BXB. And we see that the segment BD will correspond to the segment BD in the upper triangle. So they have a common side of the same length. So that means, other than being similar, they're actually congruent to each other, like that. And so that will imply that the sides are actually, the corresponding sides will also be the same. Consequentially, we must have that the h will correspond to the length xd, which is what we wanted to show. We wanted to show that d is the midpoint of the segment hx. So this is our solution for this problem. And so for the next sub problem, we are required to show that M is the midpoint of segment HY. So we have to show that first M lies on this segment, and then it is also the midpoint of the segment from H to I. And so to do that, I will first highlight a well-known result. Whenever you have a cycle that and a center, for example center O, then the angle by which the diameter will subtend at the circumference will always be 90 degrees. Will always be 90 degrees. So whenever you have a cycle, then the diameter will subtend an angle of 90 degrees. And it's easy to actually prove, because some of you may remember that the angle at the center will always be twice the angle at the circumference. Now, because this is a straight line, maybe from point X to point Y, point Z, this is a straight line, and the midpoint is the center of the cycle. And so this angle is 180, so the angle at the circumference will always be half of 180, which is 90 degrees. So it does not matter where we subtend the diameter, the angle will always be 90 degrees. So even if it's on the other side, the angle will always be 90 degrees, like that, as long as it is subtended by the diameter of the cycle. Now the diameter, as long as it passes through the center of the cycle, so there could be another diameter through the center of the cycle, but the angle will still also be 90 degrees. So that is what you should be keeping in mind, because here we have a same situation. We see that the segment from A to I passes through the center of the cycle, so it is the diameter of this cycle. So whatever angle is subtended on this cycle will always be 90 degrees. So that being said, I will draw the segment from C to I. So we have a segment here from C to I, like that. Maybe if I draw it with a red line. I have a segment from the point C to the point Y, like that. And then by this result, we know that because this is the diameter from A to I, then this angle here subtended by the diameter will be 90 degrees. So the angle ACY is 90 degrees. Okay, so we have that result. And another result is that if I join the points B to the point Y, so for the point B to the point Y, I have something like that. So again, because this angle here, angle ABY, it is also subtended by the diameter of the cycle. So this angle here will have to be 90 degrees, like that. So how can you use this to show that M is the midpoint of the segment HY? So if you look closely, you know that this is from the point B to the line BH is the altitude. So this line is perpendicular to the segment, right? And the second, we have concluded about the segment YC. So BH is perpendicular to the line AC, and so is the segment CY. It is also perpendicular to the line AC. And so that tells us that these two lines will actually be parallel to each other, right? Because they are both perpendicular to the same line. So they will be parallel to each other. So the line BH, the conclusion here is the line BH will be parallel to the line YC. So line BH is parallel to line YC. Again, for the same reasons, this line here is perpendicular to the line AB, and the same is can be said about the altitude from C. Is also perpendicular to this line. So this pair of lines, they are also parallel to each other because they are both perpendicular to the same line. So another conclusion is that a similar conclusion is that BY is parallel to CH. And so what we realize is that we have managed to form a pair of parallel lines and so the conclusion is that this quadrilateral BHBYC will be a parallelogram because the opposite sides are parallel to each other. So the quadrilateral H, B, Y, and C is a parallelogram. So we have a parallelogram here, and one famous fact about the parallelogram is that the diagonals of a parallelogram, they always bisect each other. So BC is one of the diagonals of this parallelogram, and HY is also a diagonal of this parallelogram. So we have, if you connect H to I, something like that. So this diagonal and this diagonal will bisect each other. That means this diagonal will pass through the midpoint of this diagonal, and this diagonal will pass through the midpoint of this diagonal. So they will bisect each other at the point of intersection. And this is well known about the parallelogram. And in fact, the converse of this statement is also true. Whenever you have a quadrilateral in such a way that the diagonals bisect each other, then this quadrilateral is also has to be a parallelogram. And so that concludes our proof for the second problem, that this line and this line, they tend to bisect each other. In other words, the points H, M, and Y will actually be collinear, and also the point M will be the midpoint of the segment HY. So that will be the proof of our second statement. For the third statement, we are required to show that angle BAH is the same as angle CAO. Now this one is also not difficult to prove because here we have a right triangle BAD, we have a 90 degrees here, and this is angle BAD is the same as the angle B of the triangle ABC. So this angle here, angle BAH will be 90 degrees minus angle B. So angle B is just angle ABC. So this angle here will be complement to angle B. It will be 90 degrees minus angle B. So we can denote it by a red mark. That angle over there, it is 90 minus angle B. And so again, from the same fact, we know that this angle here, angle AYC is the same as angle ABC. Why? Because the points A, C, Y, and B, they lie on the same cycle, so the angle subtended by the arc AC at the point Y will be the same as the angle subtended at the point B, right? Because they are cyclic. And so you have this result just the same as the angle B. Now this is the same as the angle B, but again you have a 90 degrees angle here. So if you consider triangle ACY, this is the right triangle at the point C, and we know that the angle AYC equals 90 degree, it equals to angle B, and so the angle CAY will actually be equal to 90 degrees minus angle ACY, which is the same as 90 degrees minus angle B, because angle ACY is the same as angle B. And so that implies that this angle is the same as the angle that we have seen before, angle BAH. And so that concludes our proof for the third statement about the angle relationships. And so what is interesting about this result is that if you look closely, because B is the midpoint of the segment HX and M is the midpoint of the segment HY, and that means if we scale this triangle HDM, by a factor of 2, then you will obtain triangle HXY. And you can use this fact to show that this scaling will also map the 9-point cycle to become the circumcycle of the triangle ABC. But that is the fact that we'll try to prove in later videos. But for now, just keep in mind that whenever you have whenever you have a relationship between O and H, is that the angles they subtend at the vertices will be the same, and that H will actually be the homothency is centered at H with factor 2 will send this point here to the point at the circumcenter, and the midpoint of the side BC to the point Y, which also happens to be the intersection of the diameter AO and the circumcycle of triangle ABC. And so that will be all for this question. Thank you for watching.